Okay, so we're going to solve one-step equations, and we're going to work with only addition and subtraction. So the first thing that I always used to teach my kids, and we used to talk about this, which everybody knows is an equal sign, but a lot of kids think that this thing means something that it doesn't. Because when I write this, and I ask kids, what does this symbol mean? When they see this, they think it means add, and it doesn't. This is what means add. This means that whatever is over here, all of this stuff, is the same as this stuff. And so when we say 1 plus 2 is equal to 3, we're saying that all of this stuff over here, the stuff on the left side, is the same as the stuff on the right side. And this is important because this shows us this is where the middle of their equation is. So sometimes I would write things on the board like this: 3x plus 10 minus 8x plus 4 minus 12x plus 3 equals 211. And I would say to the kids, where is the middle of this equation? And every year some kids would start counting things and they'd say that the middle is somewhere right in here. But the middle of an equation is always the equal sign, because this is the balancing point. So if you think of things like a great big teeter-totter, even though it doesn't look like it's in the middle, this is the balancing point for this equation. That this stuff over here, if you will, has to weigh the same amount as this stuff over here. Even though this looks tinier and shorter, all of this stuff has to be the same value as all of this stuff over here. So this is always the middle of the equation. And that's important because, as you know, your teachers have taught you that you always want to work on the left side of the equation and the right side of the equation. And therefore, since you need to know where the left and the right of the equation is, you always have to know where the middle is, because the stuff over here is the left and the stuff over here is the right. And there are two rules. There's the golden rule for solving equations. And you know what the golden rule is, I'm sure, Brody. It's whatever you do to one side, you must do the same to the other. So that's the golden rule of solving equations. It's the #1 rule for all algebra stuff. Whatever you do to one side or the left side, you must do the exact same thing to the right side. No questions. Always, always, always. And when you solve equations, you always undo things. And the way you undo things is you do the opposite. So when I talk about adding, the opposite operation is subtract. When I talk about subtract, the opposite operation is add. And same thing when I talk about multiply, the opposite is divide. Oops. And when I talk about divide, the opposite is multiply. And so when you solve an equation, you undo. So when solving equation, you isolate the variable, and you know what isolate means? It means get it alone, all by itself. And the variable is the letter, the x, the y, the z, whatever variable you are using. It's to isolate the variable by doing the opposite operation. So these are the two things that I used to teach all my kids. These are the most important things when solving any equation, even if they look like this. Okay, so we're going to go back and look at addition equations now, just the kind of the smallest ones, because if those don't make much sense, then none of the other stuff is going to make sense. So let's start with a pretty basic equation. Okay, let me just move this up here. I'm going to use the bottom of this. So let's look at a pretty basic addition equation. So number one thing about algebra, I used to tell my kids, if you can be neat, you can do algebra. If you can't be neat, you're going to struggle with algebra your whole life. So you got to keep things nice and lined up, write nice and neat, write dark so you can see it, and always use a pencil so you can erase. And now I'm using pens so you can see it, but and I like to teach in different colors. So here's your first problem. And you've been solving these for a long time, but I just want to talk through some stuff. So problem number one. Let's say I have some number, that's what x is, some number that we don't know what it is, plus 8 equals 10. And you've been doing math long enough that you know that this has to be a 2. 2 plus 8 is the same as 10. This stuff over here is the same as this stuff over here. So if you remember, if you think of this as a teeter-totter, a balance, that this stuff over here on the left, so this is the left side of my equation, here's the middle, has to be the same as the right side of my equation. So I'm going to use the golden rule. I'm going to isolate the variable. So here's the variable. I want to get that all by itself. And so I used to say to my kids, so here's the variable on the left side, the variable on the left or the right, they would say the left. And I'd say, what's over there with the variable? And they would say, adding 8. And I say, okay, we want to get the variable alone. So what do we have to get rid of? Well, that means we have to get rid of this plus 8 because we want to isolate the variable, get it all by itself. So how do you get rid of adding 8? And you know that the opposite of adding 8 is to subtract 8. Subtract 8. So I'm going to subtract 8 over here. And notice how I wrote that? I kind of lined it up right underneath the other 8, because you know when you do math by hand and you want to add two numbers together or subtract some numbers, let's say I'm doing some math on a scratch piece of paper and I want to subtract 132 and I want to subtract 10, and I would write minus 10, and then you draw a line under here and you do 2 minus 0 is 2, and 3 minus 1 is 2, and 1 minus nothing is 1, and so that's how you do a little hand subtraction problem. Well, I'm doing the same thing here. I'm going to subtract 8 and I'm going to put it right below the thing that I want to get rid of. Now, I always told my kids to always draw the line down the middle of the equation before they do anything. So we're going to subtract 8 over here. Subtract 8, so golden rule, whatever I do on the right or whatever I do on the left, I must do the exact same thing on the right. So I line it up with that, 10. And now, just like I drew a line across the bottom to show that I'm doing a little subtraction problem or adding problem, I'm going to do the same thing here. So I'm going to draw a line all the way across the bottom of this, and now what I have is 3 little subtraction or addition problems. Here's one here. X plus nothing is X. So I'm going to just do that addition problem right here. X plus nothing is X. Here's a positive 8 and a negative 8, and I think you probably know that opposites always add to 0. So here's a positive 8 and a negative 8. That opposites always make 0. So that goes away. So if I wanted to, I could write plus 0 here. But that's kind of silly, because if I ask how old you are, you probably say, I'm 14 years old. I'm not 14 plus 0, because that's the same thing. So we usually don't write that. So I'm going to get rid of that. And then you always bring down your equal sign. So I'm going to bring down my equal sign. And now since I have 10 minus 8 over here, everybody knows that that's a 2. And so now I can say x plus 8 is the same as 10. Well, now I can also say that means x is the same as 2. And you know, if you check that and plug it back in here, in your head, you can say 2 plus 8 should be the same as 10. So that's kind of the whole philosophy about solving equations. And I could do the same with a subtraction problem. And I like to think of subtraction problems, I like to think of negative numbers instead. So let's take a look at a subtraction problem or a negative problem. So here's x minus 5 equals 12. Okay, so that means some number, we're going to take 5 away from it, has to be 12. So this number must be bigger than 12. Because if I'm going to take 5 away from it, it must be bigger than 12. All right, so first thing I do is draw a line down the middle. Split my equation. I say, where's the variable, on the left or on the right? And I say, well, it's on the left here. What do I have to get rid of to make it be it by itself? I have to get rid of that minus 5. What's the opposite of subtracting 5? Or what's the opposite of a negative 5? Negative 5 and subtracting 5 are exactly the same thing. The opposite of a negative 5 is a positive 5, so I'm going to write plus 5. And I line it right up under the thing that I want to get rid of. So, golden rule, whatever I add to the right, not to the left, I have to add to the right. So I say plus 5 over here. Draw my line across, showing that I'm adding and subtracting. And I have 3 little addition problems. What's x plus nothing? X. What's a negative 5 plus a positive 5? Opposites always add to 0. Bring down your equal sign, boom. 12 plus 5, 17. And then you can always go back and check in your head. 17 minus 5, yep, that's 12. One of the other things I used to tell my kids, some kids always wanted to say negative 8, positive 8 is a 0. I told them to say, well, let's just put a big 0 over that thing right there when we're done. Same thing here, negative 5, positive 5, that goes to 0. We'll just make it go away, put a 0 there. Okay, I'm going to flip the page and we'll just try doing some of these and show you some weird things that sometimes happen with addition and subtraction equations. All right, oops, sort of bled through there. So let's take a problem like this. Here's example 3. What if I have negative 12 equals 17 plus x? Whoops, that's a plus sign, sorry. That's why I should be using a pencil so I can erase. All right, split it down the middle. Where's the variable? Left side or the right side? Now my variable's on the right side of my equation. Okay, that's no big deal. We're going to do the exact same thing. And now I say, hey, what's happening to the x? It's being added to 17. So what's the opposite of adding 17? We're going to subtract a 17. Now subtraction is the same as negative. So another way to ask it is, what is the opposite of positive 17? Well, the opposite would be a negative 17. So I'm going to write that right below the thing that I want to get rid of. Whatever I do on the right, I now have to do on the left. So I'm going to add a negative 17 over here. Notice I'm not writing the addition sign. I'm just saying negative 17. So when I'm doing these, I'm always thinking of adding. Okay. Now, negative 12 and negative 17, everybody's negative here. So that just makes it more and more negative. So negative 12 and negative 17, I add all of those negatives up and I get negative 29. Bring my equal sign straight down. Opposites always go to 0. 17 and negative 17 are gone. That's a 0. So I told my kids to do this if they want. And now I have a positive x plus nothing is a positive x. That means all of this stuff over here is the same as negative 12. That means x has to be a negative 29. Problem 4. Try this one. Let's do this. Negative 14 equals 3 minus x. Now this is a really tricky problem. Okay, so first thing we'll do is just run through this step by step. First thing we'll do, split it down the middle, right down through the equal sign. Where's your variable, left or right? Here's my variables on the right. What do I have to get rid of to make it go away? I have to get rid of this 3, and I have to get rid of this. Don't think of this as a subtraction sign. Think of it as a negative sign. Same thing. I have to get rid of this 3, and I have to get rid of that negative sign. All right. What 3 is that? Is that a positive 3 or a negative 3? Well, it's a positive 3 because we care about what's in front, and there's nothing in front here, so that's a positive 3. Don't get confused. This sign is behind the 3. The thing that we want to get rid of is a positive 3. So what do you add to positive 3 to get it to go away? You add the opposite. You add a negative 3. A lot of kids confuse this. They see this as a subtraction problem, which it is, and so they want to add here, but 3 plus 3 doesn't make it go away. It's got to be 3 minus 3 makes it go away. So I have to subtract a 3 over here because I'm following the golden rule. All right, just like before, everybody's negative here. Negative 14 and a negative 3, everybody's negative. That means I have negative 17 altogether. Bring your equal sign straight down. Positive 3, negative 3 goes away. And now, what is left over here? Negative 3 is not, or negative x is not what's left over here. Negative x is what's left over here. So we're going to have to do this, negative x. And I used to tell my kids, I don't give a rip about negative x. I don't want to know what negative x is. I want to know what positive x is. And so x is really not by itself here yet. X still has a negative sign out in front. And so we'll take a shortcut here for now, but I'll explain this in my next video. How do you get rid of a negative x? I used to tell my kids, do the flip-flop rule. I don't care about negative x, so I'm going to change it to its opposite. I'm going to change it to a positive x. Well, following the golden rule, if I change this number to its opposite, I have to change this number to its opposite. So since this is a negative 17, I'm going to flip it to its positive 17. If this were a positive 12 here, I would change that to a negative 12 there. And so there's my answer. X has to be a negative 7 or a positive 17. And you can go back and check this again right up here and say, all right, 3 minus 17. If you have 3 and then you lose 17, you're 14 in the hole. If you have, I guess that's good. End of story. Okay? Let me know if you have any questions on that one. Bye.